Hey Math 8, today's a cool day. Love today. Wish we were in the classroom though, guys, because this is a good day to write. 6-1. I love writing that date because it's always to me a signal of, hey, the school year's winding down. Man, I'm going to miss this year with you guys doing all those 8th grade activities, going to the places and that. Man, I'm getting bummed right now, guys. Oh, 6-1, but at least it's winding down for us and we won't have to do this too much more. So, volume of a sphere, volume of a ball. Okay, so let me put just something here so if I spill a little bit, I don't get it all over the paper. So how much does this guy right here hold? That much. But I don't have any secret like poured into another shape, guys. I don't have anything like that for this one. Okay, so when we draw a sphere, what we're going to do is we're going to try to make it look round. But if you go like this, it just looks like a flat circle. So I'm going to ask you to kind of like an electron. You know, if you make it look like an electron buzzing around, at least you get the sense that it's a round ball. Okay, so real quickly, I'll get you to the formula, but we got to come back here and write down the formula for each basic one because you're going to notice a little something. It has a commonality with other shapes. Remember length times width times height? And then remember the pyramid was related to this? Remember the pyramid was the same formula? It was length, width, and height, but chopped into 3 pieces. And then you had a cylinder, and that was, remember length and width was the bottom, okay, and the bottom of this is pi r squared times the number of layers, which is the height, and then you found out that a cone was related to that too. It was pi r squared times height divided by 3. Well, what I want you to see is that it's divided by 3. So every time you come up to a point where you're not straight up, and even if you go like this, and I want you guys to see, give me a couple seconds. I want you guys to see like half of a sphere. You guys might be able to see the top a little bit better if I show you half. So here's half of a ball. So you can see how it comes to a point at the top. And that's also a ball too. A ball comes to a point right here at the top, right? Okay. So your formula is simple. It's 4 pi r, careful here, last time it was squared, this time it's cubed. It's cubed. That's because you need one for this direction, a radius going this way, just like the length did. You need one for going depth, just like the width was the depth. And then you need one last going for the height. So one for the length, one for the width, and one for the height. So that's 1, 2, 3, and that's why you have 3 radiuses there. Okay, and because this comes to a point at the top, it's going to have a 3 there. Once you see that formula and you memorize that by doing it a little bit, it actually gets really, really, really easily. So let's go ahead and let's throw one of these in there, okay? Let's go do an example. I think you're only going to need to see 2 examples and you'll be ready to do some of these, okay? So let's go ahead. And to try to help see the radius, I'll do it in pink. Let's make the radius 4, okay? All right, so the first thing you're going to do is write down your formula, like always. We always write down our formula. 4 pi r cubed divided by 3. Now we're going to substitute. 4 times 3.14. What's my radius? 4 cubed, all divided by 3. Now we're going to evaluate the parts. In other words, we're going to figure out what the top is, and then we're going to divide it by 3. So according to what Ms. Dobbs taught you last year, you were supposed to do parentheses first. None of that. Exponents. So we're going to do once, twice, 3 fours in a row. We're going to now multiply that by, after exponents comes multiply and divide, so now we can just multiply 3.144 times 3.14 times 4 equals 803.84. And then evaluate it for your final answer. And so we're going to chop that into 3 pieces, and we get 267.946 with a bar over it, and that is cubes. That's how much that will hold. A ball with a radius of 4, if this were inches, then this would be 267 little tiny cubes, and each cube would be 1 inch by 1 inch by 1 inch, and you could fit almost 268 of those, just a little bit under that. Okay, that's all there is to it. Let's go do one more where they try to trick you. Okay, it's not going to be real tricky. I've done this with you, and you're going to be like, well, you've already shown problems like that. So I bet you some of you probably already know what I'm going to try to do. I'm going to try to do what they do. What does the formula call for? Radius. But what do they try to do over here? They try to give us a diameter of 10. So let's go ahead and let's write our formula down. Our formula says 4 pi r cubed divided by 3. I need a radius. But what do I have? A diameter. Well, a diameter being 10, all I've got to do is chop him in half, and I get 5. The radius is 5. Halfway across the circle is 5. And we've done enough of that by now that should come back to you. You should be going, oh yeah, that's right. Substitute 4 times 3.14. I'm going to use the x so I don't get mixed up with the decimal. If you want to use dots, then maybe we should just go like that. And that'll keep us from getting confused. Radius is 5 to the 3rd power all over 3. And we're going to do the parts. So the parts tell us that we're going to get the answer to the top and still show the 3. So 5 to the 3rd power. Once, twice, 3. That's 125 so far. Times 3.14 times 4. Doesn't really matter once you get that done which one you do next, because this is the commutative property, and that says when you multiply, and that's all you have is multiplying, you can do it any order you like. Okay? Commutative property says you can move things around and you'll still get the same answer. And we've shown that before this year. Now that you got that, all we need to do for the final answer is chop it into 3 pieces. So we get 523.3 with the bar over it cubes. So if you wanted to write it as a fraction, it would look like that. I know most of you don't, but either answer's fine. They're both perfectly good. So I'm going to go ahead and give you a few of these to do, and then you can practice those and get good at it. And then tomorrow I'll show you some more shapes. We'll kind of start doing a combination of shapes tomorrow. Okay? All right.